Right, all we're going to do in section 3.4 is we're going to learn to recognize the different kinds of functions when you see their graphs. And these are going to be the parent functions, so it's going to be the most basic version of the function, and you can add something to them or subtract or multiply them by something to make them move around the graph. But we're just going to talk about the most basic version of each of these functions. So the constant function is when you have something like f of x equals 5 or 10 or 20 or any constant number. So that function is always going to look like just a straight line, and it's always going to be horizontal. That's our constant function because it's just always equal to that same thing. All right, so then, and this is the equivalent of y equals 5, so you can see it's this one, for example, would be at y equals 5 on the graph. If we have our little axes on there. So that one would be 5 high. And if you had f of x equals 7, it would be 7 high or whatever, but it's always just going to be straight across. Now, a linear function can have a little bit more stuff. F of x equals usually mx plus b. That's our slope-intercept. So it's just going to make some kind of slanted line. It can slant up, it can slant down, it can even be kind of straight up and down, but it's going to be some version of a straight line. That's why it's called linear. Really, a constant function is a special kind of linear function because it is a line. It's just this particular kind gets a special name. It gets to be called a constant function. So here's our linear function. Then we have squared. That's what it sounds like. Any number squared. Now think about what happens when we square a number. Anytime you square a number, our positive numbers, 1 squared is 1 and 2 squared is 4, and they go up. But when you square -1, you also get 1. So when we do the squared function, we get a mirror image, and we get only positives. So this one is sitting right here on the positive section, because when you square any number, it becomes positive. So it's going to be that parabola shape because we have the mirrors, because the square of -1 and the square of 1 are the same. The square of -2 and the square of 2 are the same, and also only positive. Now, the cubic function, f of x equals x to the third, the cubic function is about when you cube something. And -1 to the third is still -1. Now, then 2 cubed is 8, but -2 cubed makes -8. So we sort of get that mirroring, but it gets a little twist here. This is our cubic function. A cubic function has kind of a mirror image on the top and the bottom because -2 squared is -8, +2 squared is +8. -3 squared is -27, 3 squared is +27. So you see it's kind of that same parabola, but it's been twisted downward because negatives can equal a negative, but then the positives all stay positive. Now let's do a quartic function. That's something to the fourth. And for that, again, it's going to stay positive, but a quartic function gets an extra little bend in it. So to the second has 1 bend. To the third has 2 bends. To the fourth will have 1, 2, 3 bends in it. To the fifth will have 4 little bends. To the sixth will have 5 little bends. So that's how we can tell all the higher powers. So this to the fourth one has 1, 2, 3 bumps. To the third has 2 bumps. It's 1 less than the power that's on there. All right, now square root is special because we can't take the square root of a negative number. So we can't even do any numbers that are over here because we can't plug a negative number in. So square root ends up looking like this. It's our one-sided function right there because the square root of 0 is 0, and the square root of 1 is 1, and the square root of 4 is 2. So it doesn't grow very quickly because roots don't get big very fast, but it just doesn't exist on this other side because the square root of -2 is not a real number. So square root shoots off in that one direction there. Cubed root kind of looks like, we can take the cubed root. The cubed root of -8 is -2. We can take a cubed root of negative numbers. So it's going to go on both sides. So it's going to look a little like this one, but it's going to continue on the negatives. And since we get negative answers when we plug in negative numbers, it's going to go down here. It really looks kind of like the cubic function turned on its side. But it also looks a little bit like the root function, but we have that extra bit added on because you can take the root of negative numbers if it's a cubed root, but you can't do a square root of negative numbers. So it has that extra piece, and also it looks like a cubic function kind of turned on its side because those functions are inverses. Then last but not least, absolute value. So absolute value function, each number, all it does is make it positive. So kind of like this one, our answer is always positive. So it's going to stay on the top half of our axis. Is only going to be up here, not down there, because we always get positive answers when we do an absolute value. But this time, it's going to make, instead of that parabola shape, it's going to make a sharp right angle. It's not going to taper off. It's going to be an exact right angle there because it's going to go 1, 1, 2, 2, 3, 3. The absolute value of 4 is 4. So it's going to make that perfect 45-degree angle here and the perfect one here, which together makes that a right angle. So absolute value you can identify with that perfect right angle that's in there. All you have to do for this section, 3, 4, on page 258, is to do number 9 through 16. So that's just going to be matching a picture of the function with the name of the function. We want to memorize those, and you will have some of these on your test where I ask you which function belongs to which name.